Okay, everyone, welcome to part 4 in our 4-part series webinar, Best Practices for your CEMS DAS. On behalf of ESC and Spectrum and Trinity Consultants, we would like to thank all of you for taking time to attend part 4 of these presentations on the role of the DAS and some best practices. My name is Steve Argabright. I am a CEMS Specialist for Trinity Consultants in the DFW and Houston area. Joining me today once again for part 4 here of this presentation is Mr. Adam Jackson with ESC Spectrum. Adam is a Business Development Manager and Coordinator with ESC Spectrum. Saying hello. Both Adam and I have a considerable experience with your DAS, the data acquisition and handling system, from the regulatory, software, and hardware perspectives, what we refer to in the industry as the unholy trinity. Both Adam and I have done plenty of field work with these systems for many years, fallen asleep on the keyboard, and been tossed off site for doing so.
That's right, Steve. So now you guys can hear me. So this is Adam Jackson, Business Development Manager for ESC Spectrum, and I'm based out of Houston, Texas. And ESC is the largest DOS provider by volume in the United States, and we also do CEMS integration, cell analyzers, parts replacements, and spares. And we like to partner with companies like Trinity for your CEMS QA/QC plans and other types of consulting for your CEMS.
All right, thanks a lot, Adam. ESC Spectrum is based out of Austin, Texas, and they provide the most widely used CEMS DAS software in the United States. Their DAS is the market leader in helping industrial and utility plants comply with your federal, with your state, with your local air quality regs requiring continuous emissions monitoring. Their professional CEMS services provide expert integration, maintenance, repairs, training, stack testing, and much, much more. Speaking for my own company, Trinity, we were founded in 1974, and we have expanded our geographic footprint and breadth of services. You can find us in our offices in just about every state out there. We have about 900 plus employees across the U.S. that attribute to our continued growth a focus on cornerstone values of top-notch technical performance and excellence in client service. Our motto is solutions delivered uncommonly well, and they bear these following characteristics. We try and be local everywhere, giving you access to our consulting services, providing exceptional quality, responsiveness, and value with some passionate customer service, some continuous improvement and consistency standards that we follow through Trinity's ISO 9001 certification. We hire our consultants through some rigorous recruiting and professional development standards with unmatched professionalism. Welcome, everybody. Today's topic, I get a lot of questions about where we start having to replace equipment. And for this purpose, I picked the one topic that I get the most questions about, and that has to do with what happens if you need to replace and recertify your stack analyzer under Part 75. What we've done here is try and create a synopsis of lessons learned and how they apply to analyzer recertification in a Part 75 environment.
And to add to that, ESC also gets a ton of questions, just like you do, Steve, on replacing the analyzer. And where we get the questions is on the specifications, new types of equipment, what are the upgraded choices, what are the differences between the companies, such as Thermo, Teledyne. And so if anybody needs help with specifications or understanding the type of analyzers that are available today, be sure to reach out to ESC Spectrum.
It's a good point, Adam, because procurement of this stuff, it's pretty much a presentation in and of itself. There are a lot of manufacturers out there, a lot of capabilities, a lot of newer types of monitoring available. Certainly a lot of digitization of this equipment over the years. It still sits in the same size box, but it's a lot more chassis and less parts to have to contend with. And that is an excellent question to have to contend with. First off, why do you want to replace it if it's not broken? Analyzers tend to have a lifespan, and if your analyzers are, kind of approaching the 10-year mark, that analyzer could be approaching obsolescence, could be out of manufacture. Your analyzer can have a poor material history, which means it requires more frequent repairs, lots of call outs, more frequent part replacement. Your analyzer that you're looking to replace may be non-standard. You may be looking at, trying to make it more standardized. If you have a number of units that use one type of analyzer versus an individual unit that uses another kind, that means more spare parts in the warehouse, more maintenance, different procedures altogether. Sometimes the analyzer parts and services can be limited based on the vintage of that analyzer, which easily indicates a start of the obsolescence of it. And one of the biggest indicators is why you should consider replacing it is when you start finding refurbished models of them on the web and third-party fire sale resellers. So here's some
And we
budgetary
stay at,
costs. Yeah, go
yeah,
ahead,
so
Adam.
let's go back to that. Let's go back to that refurbished. So we stay up to date on the obsolescence schedules. Those are published by each of the manufacturers. So if you guys don't feel like going and contacting every single one of them, and there's so many different manufacturers out there, we can give you the obsolescence for all of them with one-stop shop. So if you want to make that phone call and go through your list of equipment, we can tell you what the next scheduled obsolescence date is for each component that you've got.
Now, some budgetary costs that you need to consider when you're replacing them, obviously, first one would be the analyzer cost itself. And this is really going to vary between manufacturers. If you're looking at a direct purchase versus going through an integrator, an indirect purchase, what type of analyzer do you want to get? What kind of capabilities should it have? Would this give me the opportunity to reduce a single point of analysis to multi-point analysis, consolidating everything to one box? There are pros and cons associated with that. Do I need an additional sampling pump to go with it? What do I currently have versus what do I want? Any additional mounting hardware that's going to be associated with this box? Are there any additional options, extras? Purchase of this analyzer add any new I/O points that I'd want to use? Any brand spanking new analytical features associated with it? And because it is an analyzer replacement, it's probably going to need to be treated like a project, meaning that there's more than just the replacement of the box itself. You're looking at potentially new schematics, a regulatory review. Just like any project, you need scope, budget, and schedule, how these things are going to interact and what's going to happen towards the end. What's its purpose once you get it all done? You need to figure internal and external labor costs associated with installation, how that's going to affect this. You need to arrange and schedule stack testing for the initial certification. What needs to be done internally? What's going to be accomplished externally? And one thing that people tend to not think about until the very last minute are any reference gases that are associated with the certification of this new black box. Do I want to go with single concentrations in my bottles? Do I want to get a blended concentration? Can I do some consolidation there? Give my techs less to look forward to rather than more.
Yeah, and one of the key advantages to using an integrator such as ESC Spectrum and a partnership with Trinity is that we've done so many of these projects with so many different types of technology that we've typically got a budget already in mind and help guide you and your team with your next CEMS integration and helping you go through the project and writing the RFP and going through the whole scope to ensure that you've thought through everything.
And really, it's not just the regulatory side of it. I mean, between Adam and I know there's a lot of technical specs associated with proposals that have to be addressed as well. Those are usually done in concert with a regulatory review. What kind of information you're going to need to retrieve and how that affects retrieving it from the hardware, passing it through the software, turning it into a regulatory report, things of that nature. Now, as far as the replacement project itself, I've tried to hit some of the high points associated with it, where if you have an engineering or environmental group, their level of effort for both engineering and regulatory needs to be defined. You need to plan time for demolition versus installation. You need to plan for any updates that would need to be made to plant schematics on the QA/QC plan itself. Are there any potential programming changes, certification tests, certification event records for the DAS that you need to at least be aware of when these tests occur and have to be submitted? It's not really a well understood concept that during certification, if you have any bias adjustment factors in effect, that bias adjustment factor is a solid 1 during certification testing. That is Part 75 law. And finally, the installation scheduling itself. Are you going to do this while the unit is running? Or are you going to wait for an outage? These are all important things to think about. Other stuff, like an ECMPS, updates to your monitoring plan. You need to come up with new component IDs because your monitoring plan is dynamic. You can't get rid of the old component IDs. You can't reuse the old component IDs. You need to retire the old component IDs once certification takes place. Are there any NERC networking guidelines you need to consider for this stuff? Are you making your state notifications on time? Once you get all this certification testing done and documented, you're going to need to send a copy of it to the state. That's 45 days after the fact.
And that NERC piece has become very critical in the last couple of years, and it's one of the most common questions we get is that we're upgrading to TCP, IP, or Ethernet on any of these analyzers on the front end. How do we remotely access, or how do we gain access from a contractor perspective? And we've got a lot of case studies and have done a lot of this work with NERC successfully through the CIPs. And so if anybody has any questions on the cybersecurity aspect of CEMS or DOS in general, feel free to reach out.
And there's some important questions about NERC because not every region does it the same way. Everybody comes up with their own interpretation. It could be something as simple as a 1-line diagram that needs to be updated, or it could be something as complex as not only updating diagrams associated with this stuff, but federal updates that you have to make through NERC as well. Tickets that need to be manufactured, approved, coordinators have to be notified, etc. The list can just kind of go from there. With regard to monitoring plan revisions on this stuff and new component entry, anytime that you're looking to replace an old analyzer with the new one, those new analyzers require new component ID numbers to be added to the monitoring plan. Your old CID has to be retired. It requires an end date and hour. The new CID requires a new begin date and hour. And this will usually coincide with what we'll talk about as a conditional start date and hour in your certification event records. The new component has to be associated with the appropriate system ID. And once everything is accomplished and you believe all the I's are dotted and the T's are crossed, you evaluate your monitoring plan for errors, and where applicable, I know DAS systems that allow you to do this, you import that XML monitoring plan to the DAS software. I know Stackvision does this. I know that there are plenty of other DAS systems out there that do this.
Yeah,
So
and if you have any questions on monitoring plan, let's back up a little bit on the actual process, because there are a few other things to consider with going through your analyzers and making sure that you've got the right component IDs. And just like Steve said, you don't delete anything off the plan. It's got to be like blockchain, meaning that you want to see the historical history of all your analyzers. And this is something that I've used Trinity to great success on some of my facilities, personally, having them review the monitoring plan up front. And this is usually the first place that I start, even before going through an analyzer upgrade or replacement, or even adding a new one, is start with the monitoring plan and go through and do a mini audit of it, and then go back and refer back to your CEMS QA/QC plan to see if you've got a correct monitoring plan QA/QC plan match at the beginning, because if you're not starting off with a solid match between CEMS QA/QC and monitoring plan, it'll be a lot more difficult and challenging once you start changing things down the road.
Right, because once you add that new component, we're just kind of like talking an overview here of a component entry. But what this will mean is that you're going to be making changes in several locations of your monitoring plan. You're talking about the component itself, adding that to the system, any dates and times associated with that. So let's dive in. What we're about to talk about is the list, the litany of full system recertification testing for analyzer replacement. And this is, once again, how Part 75 defines it. Full system recertification testing generally starts with a provisional daily cal. It's also known as a probationary cal. It is generally defined as the first passing online calibration from installation. You'll also have a 7-day drift test associated with that, and that has to occur 21 consecutive unit operating days from that provisional cal. You'll have cycle response, also known as cycle time testing, which has a 168 operating hours time limit on it from that first cal, along with your linearity check. Your RATA, which is normally the last test in the sequence, has to occur within 720 operating hours from that first cal. And once all of the certification testing is complete, you have your test record entries and event record entries for the quarterly report for the EDR. And what I've kind of put here, you know, a start date and hour, which starts the event, a conditional start date, which is usually that provisional calibration date and hour, an event code and test code associated with non-like kind analyzer replacement, and the tests themselves for 7-day cycle time, linearity, and RATA. And that end date hour will generally coincide with the last test hour in the sequence, which once again is usually RATA. And this last bullet on here, where RATA is normally the last test in the sequence, there are those instances where people are still running 7-day after the fact. But if you do that, there is a potential that if RATA is not the last test, you could wind up with additional certification event records. I believe this is still a standing ECMPS issue, which, if you run into a headache, may require some additional support from the Clean Air Markets Division, or CAMD, to get past. I'm not going to get too deep into that. I just kind of want to let everybody know.
Yeah,
Go ahead,
that is an issue. Yeah, that's still an issue, Steve. And I want to add that, you know, as a prior plant engineer working at a 2-on-1 combined cycle, having managed several RATAs, I highly encourage you that if you're thinking about replacement or doing an upgrade for an analyzer that's going to trigger certification testing, that you do add it to the budget for at least a consulting review. Go reach out to a Trinity and have them go through all the notifications, have them go through the monitoring plan, have them go through the CEMS QA/QC plan, and essentially go through the checklist of all the regulatory to-dos. And then you can reach out to a company like us, ESC Spectrum, and we can help with the EDR part of all the that put into the DOS on the front end, working in harmony with Trinity. Also, we can do the on-site maintenance, so we can help with the linearities, we can help with the RATAs, and actually perform those tests for you. And you'll have a one-stop shop package to where you've checked all the boxes for regulatory. You've got a way to reach out to the CAMD system, and you've got everything entered into the DOS appropriately. So when you go push the button, you don't have any critical errors spitting back out at you.
And even if you do, you have a resource available to kind of give you a hand with them. I don't know about you, Adam, but I always found the ECMPS cross-check codes a little difficult to read without a seriously stiff cup of coffee.
It can be a challenge.
So let's talk about the individual compliance tests. first one being our probationary cal, and this is your first passing online calibration once they fire up the unit. It establishes a conditional data validation, meaning that this is the beginning of the test. All of the data associated with this test is conditionally valid. Condition being that you pass all the remaining tests. Because this is the first cal, it can be used as day one of your 7-day drift. The downside is that the pass-fail criteria is treated like initial certification. It is 1 times performance spec. I didn't find a decent enough photo of the table to import in here. I kind of hit the high points on this. But what you're looking at right now is that pass-fail criteria on SOX and NOx is about 2.5%, unless you're below, I believe, 200 ppm, and then they reduce it as an alternate to 5 parts per million. For your diluents, CO2 and O2, you're looking at 0.5% and 3% on flow. There are certain alternative performance specs available under certain conditions, and it's a healthy list. But yeah, you find a lot of mention of these tests under 75.20 and Appendix A sections 3 and 6. The next test, 7-day drift. 21 consecutive unit operating days after the first cal on the new box. And it has to be performed on the affected system components, where you're talking about a NOx diluent system, SO2 system, etc. And perform dual range testing where it's applicable. Once again, it's the same pass-fail criteria for the 7 days, and they need to be 7 consecutive cals as well. If you run into any kind of problems with it, 7-day drift is the place to have them, because it is the only test in the list that can be restarted during certification. Also, you can't really cherry pick the cals. It needs to be pretty much 7 uninterrupted, and preferably a separation of 24 hours between each, preferably. Your cycle response or cycle time test, 168 consecutive unit operating hours. Must be performed on the affected components during normal operation. And yes, dual range applies here as well. The order of testing requires the use of a 0 reference bottle for the downscale and a high span bottle for the upscale. And without getting too deep into it, the end result is that you record the time in minutes to achieve a 95% step change from the stack flue gas concentration value to the bottle value itself. And the total time of the test, in accordance with the regs for both 0 and span, is less than or equal to 15 minutes. I pulled these directly from these diagrams directly from the regs. What you're looking at right now is, hopefully this is clear enough to everybody, you are looking at a stable monitor reading the stack emissions themselves at 0.0 there. 4 minutes pass, we're injecting cal gas. In this case, because of the downscale, we're injecting the 0 level cal gas at minute 4. We are observing the cycle time for, in this case, those 4 minutes. This is not absolute. No 2 systems are alike. Your cycle time may be different. Could be longer, could be shorter. But the idea there is that once you achieve a 95% change in concentration, you record that time and the value. Minute 15 out there, once again, your results may vary, is where the cal gas reading finally stabilizes. But the point that you're concerned with is that 95% step change, which in this case is at minute 8. Handmade in here is the upscale cycle time test, the brother to it. Once again, we start from a stable monitor reading. Flue gas emissions. In this case, minute 5, we have injected a high level cal gas. We are observing the cycle time, which in this case is, in this particular example, is 6 minutes. and we are looking for that 95% step change at minute 11, that minute, that value, how long it took us to get to 95%. And here at minute 16, now we're, stable cal gas readings, and the test is just complete. Really, the test was complete at the 95% step change, but you need to observe to be certain. Now, the linearity check. Also, 168 consecutive unit operating hours after first cal, requires a low span, a mid span, and a high span bottle at these percentages: 20 to 30% of span, 50 to 60% of span, 80 to 100% of span. Your sweet spot on these values is pretty much in the middle, where you kind of like to try and shoot for a 25%, between 50 and 55%, and probably between 85 and 90% of high. Your pass-fail criteria is the absolute value of the reference gases, the average of the reference gases minus the average of the actual gases, and that it is less than or equal to 5% of the reference gas value at each level, or 5 ppm for NOx and SOx, 0.5% for CO2 and O2.
And I'd like to point out here, Steve, that it may seem obvious, but it still needs to be said that you must have had passed the linearity prior to doing the RADA. I have seen it where people have done the RADA and then tried to go back and pass the linearity. That is not going to work. And if you need any help with any of these types of tests or any of the programming in the DOS, most DOS, including ours, do all of these tests for you and will record the data. And so if you have questions on how that works, if you have questions on how your DOS is doing this, feel free to reach out and we can walk you through these steps.
And the regs do make that reference that you want, follow the order of the test the way we were talking about here, that get them done, get everything else done before RADA, because once again, RADA is normally the last test. EPA even makes that recommendation: get everything else done prior to RADA. Keep everything passing prior to RADA. And speaking of the RADA and bias test itself, you've got 720 online hours after first cal to get it done. The RADA is going to compare your actual measurements to the tester's reference method data. You're going to report a minimum of 9 test runs at each tested load. Whereas you're normally, you'll test at normal load, usually for a gas RADA. Flow analyzers can require a multi-load RADA. When you're talking about a gas RADA, there's a minimum of 21 minutes each run. You're talking about flow, there's a minimum of 5 minutes for each run. You will perform bias testing. Usually that's done concurrently during relative accuracy testing. On your NOx, SOx, and flow systems, there's no bias associated with CO2 or O2. And there are your incentives for passing on a semi-annual basis, which is 10% relative accuracy. That's your main performance specification. There are your alternates and the conditions associated with those alternate performance specs. 10% relative accuracy is good for 6 months, as opposed to your annual incentive, where your test frequency is 7.5% for you to run the RADA once a year. And if you're talking about being a low emitter out there, you could be looking at having to pass on, plus or minus 0.015 pounds per million on a NOx diluent system for an annual incentive. The certification test records that you have to create, these test records are going to contain all the relevant information that demonstrates and summarizes those test performance and completion. 7-day cycle time, linearity, RADA. Individual test records for each. You would usually submit them in the quarter that they occur. It is possible to have a cert test that crosses a quarterly boundary, but it's not advisable. Wherever possible, try and do this, try and schedule this to begin and end during a reporting quarter, during a calendar quarter. Try not to cross that quarterly boundary. It becomes a huge pain reporting wise to try and get all this in. Your event records. Those will contain the start and end dates and hours of your testing. Conditional data validation start date and hour, a QA event code, and a QA test code. And that start date and hour begins in the hour when analyzer installation begins, and there's some wiggle room in there as to when that date and hour actually occurs. But your conditional data validation date and hour will correlate to that provisional cal, that probational cal, that first online cal. And the last entries in there, as far as the end date and hour of that event record, would generally coincide with the final test completion date and hour that you pass. Once again, normally associated with the hour that you complete your relative accuracy test.
And provided that you have your DOS set up properly, and many DOS vendors should spit out a QA file that is going to have all of this information already prepackaged, ready to go, that is then submitted into the ECMPS. And just so you realize, you don't have to wait for an EDR to submit a QA file. You can submit a QA file at any time. And this is something that before you do it, you might want to have your DOS vendor review the data, since it's during a certification, to make sure before you push the button that everything is going to check out and that you don't run across any critical errors.
All right, particularly on the subject of RADA, if your stack tester is not providing you an XML format that you could potentially import into your software, pressure them to do so. It's the 21st century. This stuff exists. You should be able to, I think the point I'm trying to get at is that when it comes to RADA, you don't want to try and fat finger all this stuff. It really is a pain, particularly on a flow RADA. That's a lot of information. I would not want to torture anybody with that particular exercise. So as far as any compliance concerns, it's important to remember that your recertification testing affects any monitoring system that contains this new component. You know, if you're replacing your NOx analyzer, well, now you're potentially looking at having to recertify a NOx diluent system, which means that you're reporting recertification testing on both your NOx and diluent components. What if you analyze the NOx analyzer that you replace, or SO2 analyzer that you replace, is dual range? You're doing QA testing on both ranges with these exceptions. If, say, for example, your instrument span is less than or equal to 50 parts per million, there's no 7-day drift required on it. If you're less than or equal to 30 parts per million, no linearity, unless we're talking about MATS for SO2, which they were kind enough to add back in with the MATS rule. And finally, on this particular topic, please don't forget that your stack flow has interference checks. It really is a sad day to run checks on this stuff and forget to run interference tests as well. That can have some pretty dire consequences.
That sure can. And also, part of a compliance concern is where to locate the probe in the stack. And sometimes there's not enough real estate, and maybe you're adding an additional probe. Just know that that probe location isn't by chance. There is an engineering spec, there's a performance specification that says that this probe specifically has to be located here in the stack, and you can't just take a probe out and put another probe in, or remove a probe to do a RADA of another probe. You've got to have a good engineering basis for why the probe is located where it's at. And if you have questions about that, feel free to give us a call.
Now, I think that pretty much does it for this presentation. Adam, are you seeing any questions coming through?
Yeah, we've got a few coming in. I've got the question pane. I'm going through them right now. And let's see here. Yeah, so one of the questions is related to the DOS operation. Do you need to do in the DOS prior to doing the analyzer upgrade or replacement? And really, if you're going to do an upgrade or replacement, you're literally starting from scratch and going through just like you would be doing a build of a greenfield site. So it's a good opportunity to treat it like that, and it's a good opportunity to go back through your permit, review the language in the permit. It's a good opportunity to take a look how the DOS is actually programmed relative to your permit to see if there's any changes that need to be made on the front end. It's a good opportunity to go through your CEMS QA/QC, contact your consultant like Trinity, and they can help review the CEMS QA/QC, update it as necessary, go through the monitoring plan, and then contact ESC Spectrum or your DOS provider to make sure that all the new data associated with your replacement is put into the DOS prior to doing any of these tests. You don't want to be doing the tests and find out something's wrong and then have to schedule downtime or have to schedule the load again into the system for the RADA, because that can be a costly mistake. Let's see, we've got another question here. Let's see here. In a dual range analyzer, do I need to run cycle time tests for both high or low ranges? So I think, Steve, you just answered that. Do you want to expand upon that one a little bit?
Yes, you do. Yes, you do. There don't seem to be any exceptions when it comes to cycle time or cycle response. Dual range testing is required on that.
Okay.
But it's important to remember that you need to ensure that you are using a high span bottle on that low range. I've had to check too many people on that where they have historically utilized a mid-range bottle, and it does require a high span bottle for both the high range and low range of an instrument.
Okay, we got another one here. It says, in part 75, I think it mentions to run the cycle response time test 3 times and select the highest of the response time. Is this correct? Steve, would you like to expand upon that?
Ooh, I have heard of this. What I believe they're referring to sounds like test injection procedure, but I don't believe that I have to go back and examine that more closely. I don't remember anybody doing it 3 times. The cycle response is a system level single injection test. You can run it as many times as you want, but there is, within the test record structure, you're only reporting the beginning and the ending of the injection where you achieve that 95% step change. Now, both legs of that, the zero and the span value, have to be reported as a set. It's a single test with 2 legs to it, the zero and span value. But I don't believe that I'm aware that you have to run it 3 times.
Yes, on this one, what we'll do is for whoever asked this question, we'll make sure that we go through and do a little review of the reg, see if we can locate exactly the reg, and Trinity will reach out to you on if there's any potential questions that need to be answered for your specific application, because some of these things can be case by case.
Yeah, if you can forward that question to my email address, I can take a look at that this afternoon.
Okay, and then the last question here is switching brands. Is there a difference between, thermo, Teledyne? And the answer is really no. So it's really your preference at the site as to what type of technology you are comfortable using. And Steve, you had mentioned earlier standardization across the fleet. And so it's your advantage to have a standardized fleet, so that way you can have spare parts on the shelf. You can have a swappable situation if you have multiple stacks that are identical at the site. And so if you have a mixture of technologies, which there's a lot of sites that still do, it can be a challenge trying to find spare parts or having to stock two different brands worth of parts. And so if you have any questions on obsolescence schedule, is your analyzer, too old to support? Is there any advantages between specific brands such as Thermo and Teledyne? Feel free to reach out to ESC Spectrum. We can walk you through all the technologies because we are an OEM and represent them all and can get you a quick response and go through the engineering analysis for which one would probably be the most advantageous for your specific application.
Right. I mean, other than the obvious differences in brand name and probably color of the box, pretty much what you had in there before, whether you're talking about an ultraviolet measurement or a chemiluminescent measurement associated with SOx and NOx respectively, it's probably going to be very similar in measurement technologies what you had before. Pretty much everybody's going to fit into a 19-inch analyzer rack. Everybody still has to take a sample. If you're talking about going between something like an ultrasonic flow monitor versus a differential pressure type flow monitor, yeah, there's some obvious distinctions there. But if you're comfortable with a particular type of measurement, you can switch between manufacturers fairly easily with, I want to say, minimal consequence.
That's correct. And we've got a couple of more that have just come in. So we got some comments here. So the 3 times. So the original question was the 3-time cycle response time. Can you pick the highest of the response times? That's actually a Part 60 requirement. Part 70 is only 1 time, as you had stated, Steve. So if you are a Part 60 site, yes, you do have the option for the 3 and picking one of them, the highest of the cycle response times. But for Part 75, it's a one-shot deal. And then we have another here is that you can't pick individual tests to submit when you use ECMPS under Part 75. When you submit the QA file, everything there will be submitted for that unit. So be sure that it's all ready to go prior to pushing the submit button. So that's a good point.
Excellent point.
And so that wraps up the question. So if anybody has any other questions or if they think of something after this presentation, our contact information is on the slides. Oh, we've got more. Okay. But if anybody has any questions, yeah, they keep coming in. We got any additional questions after this presentation, make sure you send us an email. You can send me an email or Steve an email, or you can give us a call or text and we will respond to you. So we've got a few more that keep coming in here. Can we get a copy of the slides? We'd love to show this to our O&M supervisors. Of course, yes. So that is the purpose of us doing these types of presentations. We want to show value to you, your team, and give you the resources so that way you can go do these at the sites. Now, we will also give a presentation specifically to your site as part of our reaching out process. So if you would like us to give a presentation specifically to your O&M personnel, we can do that. And typically we do it at no charge, and we can do this using the virtual technologies that we've all learned how to do during our quarantine. So if you have any interest in us giving a more specific presentation directly to your site and going through even multiple shifts, I know, Steve, you probably have no heartburn, and I don't either. We work weekends, nights, we work power plant schedules. So if you have other shifts that need help, we can also give a specific presentation to those. But we will also provide you the slides if you want to give the presentation yourself.
He's absolutely
next,
right. This is why our keyboards are padded, so we can sleep on them. So
that's right. CEMS never sleeps.
CEMS never sleeps.
Our plant is looking. Here's another question. Our plant is looking to upgrade our CO, NOx, O2 analyzers with ESC or Trinity to be able to provide us a comparison chart with different manufacturers. Also, would like to upgrade our sample conditioning system. So yes, we would be able to do that. And that is one of the advantages of going to an integrator like ESC Spectrum is that we're not biased to any analyzer manufacturer. We're OEMs and support all the majors and even odds and ends. So we can source and supply anything. And so we've got hundreds of examples, if not thousands of examples of unique installations using all the major brand name technologies. and we can help you for your specific regulatory case and technology. And if you're a coal site, a power plant site with a natural gas turbine, we can help you go through the selection process and give you the pros and cons, plus a budgetary estimate for what you're looking at cost-wise to move forward. And then Trinity can definitely give you a budget and help you through all the regulatory aspects of going through the submittal process, the notification process to the agency, the CEMS QA/QC plan update, monitoring plan update, and then going through the initial compliance testing. And then we can help actually do those tests. So that way you're ready to go, full package done. You're in regulatory, in compliance, push the button, and you have nothing but blue skies when you submit to ECMPS. That's what we want. So I encourage, we'll reach out to you individually. Yeah, go ahead, Steve.
Right. You still had, just curious, it sounded like you had some more questions coming in.
I think that's it. Let's check here. This is great. We got a lot of folks chiming in. And so again, if you think of something sometime middle of the week, I should ask that during this presentation, feel free. You can bug us. We will help get you the answers. If we don't have the answers, we will find you the resource to get you the answer to your question, whether it's regulatory or if it's engineering equipment specification based. Either Steve or myself can help get you those responses.
Yeah, there's my contact information on screen. As always, free publications out there, the Plain English Guide to Part 75, the 2013 version of the Emissions Monitoring Policy Manual for Part 75. It's all easy to read. There's my email address. That's a phone number. Find me on email, it's easier. There is ESC Spectrum's website, their main resource library. Some general inquiry number, and there's Adam's contact information. I'm going to make one final plea to anybody out there who has any further questions about this stuff. If not, you've got our email addresses, you've got some potential phone numbers anyway. Let's hope they work. Before we go, Adam, do you have anything else you want to share?
Well, I just want to thank everybody for their time, and be sure to check out, if you haven't seen this webinar, if you have questions about part 1, 2, and 3 of this 4-part series, this is part 4, feel free to reach out to us, especially if you're going to be giving a specific presentation to your O&M staff. You might want to have the other materials. If you've missed them, we can help get those to you as well.
And on behalf of Mr. Jackson and myself, I want to thank each and every one of you for sticking it out through all 4 of these complimentary webinars we've been putting out. The knowledge is meant to be shared. That's why it's free. We know there's a lot of people out there that are winding up in environmental positions that, now they fall under Part 75 regs, and it can be a little new and a little intimidating. It's not as bad as you think. It's a very clear set of regs, but it's just a very stringent set of regs. If you need help, here's where we are. I'm with Trinity. Adam's with ESC Spectrum. You've got our contact information. We'll be more than happy to give you guys a hand with this stuff. On behalf of Mr. Jackson and myself, y'all stay safe, stay healthy. Take care. Bye now.